Hi, we are back here, 2.4, which is my favorite one. I'm so clever. The laws of logarithms called the LOLs. Haha. I know everyone's laughing out loud right now. Oh my gosh. And the change of base formula. So we're going to talk about the laws first, and all the 7 major ones are here. The actual laws, the LOLs, are these 3. And these are mainly what we're going to be working with. But I wanted to point these out as well. And these I don't really make a big deal about because you can I guess figure these out by just like working out exponential equations like we've done already in 2.1 to 2.3. But I'll just point them out. So this one, I'm going to talk about these first. The log base b of b. So if these two are the same, it equals 1. And that sort of works out because if you change this to exponential, you get b to the first equals this b, right? And so we know that's true. B to the first equals b to the first. So if I have these two being the same, it equals 1. Obviously, you could have figured that out by changing just into exponential. And so I don't really go through that one. The second one is here. If I have b to the 1, so this, no matter what it is 1, is always going to equal 0. And for the same reason, b to the 0 power equals 1, right? And so no matter what, if out here is 0, then this number is going to be a 1. If this is a 1, then out here is 0. In order to talk about 6 and 7, I'm going to talk about the LOLs first. So there's 3 major laws of logarithms, and you'll see them in sort of red and blue. And so you'll notice that in all 3 of these, they have the same base, right? B, 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 and B. And so the bases have to be the same in order for these to work. If the bases aren't the same, then this doesn't work. But, so in number 1, if I have log base b of m times n, so m and n in here are multiplied, then they can expand, okay, to be log base b of m plus log base b of n. So the m comes here, the n comes here, and basically if you're multiplying, it turns into addition. Okay, so you multiply them here, it turns into addition here. And so this is called expanding, or making the logarithm larger. There's also condensing, which means you'll start here and work backwards. Okay, so this can go either way. It's a double arrow there. The second one, log base b of m divided by n. So this time instead of multiplication, I have division, is going to turn into subtraction. So log base b of m minus log base b of n. And so they separate, the m is first, the n is second, and you subtract. And this can go, again, this way and expand, or from here to here and condense. Okay? And the third one is if I have an exponent. So log base b of m to the n power. Okay, so this right here is an exponent. Okay, and so if this happens, the n, you can come and make it the coefficient in the front of the log. So log base b of m is what I have here, and then the n comes down into the front. Okay, and this is multiplied here. And again, this can go back or forth when you're expanding or condensing. Okay, and so those are the 3 L's. And so this third one is what relates to 6 and 7 here. So if I have log base b of b to the k, well, again, these b's are the same, right? And so this k comes down to the front because this is an exponent using LOL number 3. And so this now becomes k, I'll bring this down here, times log base b of b, right? And we know in number 1 that log base b of b turns out to be 1. And so this goes away sort of and becomes a 1. K times 1 is just k. Okay? Same idea here. This log base b of x in number 7 is an exponent. And so this can come down. You know what, actually, I don't know if that's true. I'm gonna retract that statement. I can't bring this down in this case because there's not a log here. This is actually an exponential form. And so, okay, eraser. This doesn't actually come down, but because exponential and logarithmic are inverses of each other, if I have a base here of b and a base here of b, these sort of cancel each other, and I'm left with x equals x, okay? And so you might see some of them with these, but otherwise you can work them out using other things. So let's try some examples using these LOLs, okay? The first, the second, and the third. So my first two directions here say expand, all right? So I'm going to make these larger. And I start by following the usual rule. So here in number 1, I have log base 8, x divided by y to the 5th, all of this raised to the 2nd. So using PEMDAS still, I want to look in the parentheses. There's nothing I can simplify in here. So I have exponents. And so when I have an exponential term raised to exponents, what do? I multiply. Okay, and so this is x to the first power. And so I multiply here and here. So this gives me log base 8 of x squared, right? Because that's 1 times 2 over y to the 10th. Okay, so first step. Next, I see I have division, and I also have some exponents. So if I look back at the LOLs, I have an exponent one, and I have division here. So I'm not using LOL 1 here because there's no multiplication. But I have this division 1, which I know turns into subtraction, and this exponent 1, the end comes down into the front, the exponent. And so I'm going to do the expanding first, meaning there's 2 different terms here. So I'm going to make it into 2 different terms. The log base 8, remember this stays, right? Both of them have to have the same base. So I have log base 8. Using LOL number 2, I'm going to start with x squared of x squared. No, don't do that to me again. And then I also have this y to the 10th, but that also needs the log base 8 term. And since it's divided, this is going to have subtraction here using LOL 2. And again, I have log base 8 of y to the 10th. Okay, so that was separating it using LOL 2. The division becomes subtraction. However, I also have these exponents, and so now using LOL 3, these exponents are going to come down and become coefficients. Okay. Okay, and so the 2 comes down here, becomes a coefficient, so I have 2. Oh my gosh. Two times log of 8, log base 8, oh my gosh, I'm sorry, of x minus, this 10 comes down in front, 10 log base 8 of y. Okay? So bring the 2 down, and then this is your expanded, this is your answer. Okay? So number 2, let's see here. I don't see any exponents right now, and I don't see any division, right? I see some multiplication, and I see this root, this third root. So we're going to have to deal with that. But I see this multiplication, so I think I'm going to use, don't not respond, active inspire. Okay. I see multiplication, so I think I'm going to use LOL 1, right? So we add here. And so this is why we did 2.1. I have this third root. If you remember, and this third root is only over x and y. And if you remember, I also could have my exponents here, right? So in order to evaluate this, I need to change this not into a root, but into exponents. So I'm going to have log base 6 of z, and I have x and I have y, x and y. But I don't want the root anymore. And so if you remember changing this root into rational exponents, this x becomes 1 over 1/3 power. And same thing for y. Okay, so I have z, because that wasn't under the root, x to the 1/3 and y to the 1/3, because this becomes the denominator and the exponent here becomes the numerator. Now these terms are both multiplied, so I can expand them using LOL1. There's 3 terms here, so I'm going to have 3 separate parts. This one only had 2 because there were only 2 terms. So I have log base 6 of z. They're multiplied, so I'm going to add using LOL1, log base 6 of x to the 1/3, and then again multiplied log base 6 of y to the 1/3. Okay? But you'll also notice that we have these exponents, and so these have to come down to the front. Eventually you can do this step in one. If you, once you figure these out, you'll probably think to yourself to do that all at once. But here we'll do it all. So the 1/3 comes in front to the coefficient, log base 6 of x plus 1/3 log base 6 of y. And there's your expanded. Okay. All right, let's roll some dice. Add this up, put it in your CPP. Okay. All right, this one is condensing. And so this is, condense means to make smaller. So here I have 2 terms, I need to make it into 1. Here I have 3 terms, I need to make it into 1. You'll notice that these are ln, these are natural log. It's okay, the same rules. The LOL still work for natural logs. Okay, so what I notice in number 3 is I have some coefficients. So I know that these are going to come up to become exponents. So log base 5 of x to the 3rd minus log base 5 of y to the 18th. But I still have 2 terms, and so I need to make them into 1. I have the same base, and remember, just like these started as 1 term, right? So they only had 1 log base 6, 1 log base 8. So the same thing here. I have log base 5 and only 1 of them when I'm condensing, because I'm condensing into 1 term. I have subtraction, so this is LOL2. Subtraction turns into division, right? So I start with the first one. This becomes the numerator, x to the 3rd over, because the subtraction turns into division, and log base 5th we already had here, y to the 18th is in the denominator. And that's your answer, condensed. Okay? In number 4, I have ln's, but that's okay, same idea, condense again, so I'm going to condense into 1. This time I have 3 terms, but that's okay. Coefficient here is 1, 1, so even if I bring it up, it's going to stay the same. But here I have a 5, so I know this 5 has to come up. Up here, so this becomes a 5 in the exponent. I'm just going to do that in the first step. And so now I also notice these are all added, there's addition, and so this is LOL number 1, and I want to make it into 1 term, right? So I have ln 2, making it just 1 ln is all I need, 2, the plus 5 turns into times 5, plus again 3, we already put this exponent this 5 in the exponent, times 5 to the 5th. And that's it. You don't have to evaluate those numbers. This is just condensing it into 1. Okay? All right. The last thing is the change of base formula, and this is pretty simple, pretty quick. Just a few things here. This is used when logs cannot be evaluated using exponential functions. Okay? So exponential functions were what we covered in 2.2 and 2.3. And when I can't do that, when I can't solve with exponentials, I can use the change of base. So essentially here is what it says. X, A, and B need to be positive. A can't be 1, B can't be 1. And we've already talked about that. The formula says if I have log base A of X, okay, so A is the base, X is the number, and the same level as log, that I can evaluate that with my calculator by doing log base B of X divided by log base B of A. So here's, you'll notice, the B's are the same. B's were not in here. So the B, you can put anything in here, but it can't be 1, okay? And it can't be negative because they have to be positive. And usually this note here, b will be the 10, the common log, or e, the natural log. You can use either, and we do that so that you can evaluate on your calculator. You can make it other things, but then you'll have to evaluate it by hand, so try 10 or e. And then, so log base b, x divided by a. Well, x comes from here, a is the base, and so those numbers are what goes in there. Okay? Pretty simple, really. And so let's try. Use a calculator to approximate each of the nearest to the nearest thousand. So log base 4 of 2.5. So this is a and this is x, right? So this equals log base b. All right, well, usually b is 10 or e. So I don't really have to write b. I can just write log of 2.5, right? X is the one in the numerator, so that's 2.5, over log of 4, because that's the base, that's a here, which comes here. And that you evaluate on your calculator, okay? And so I pulled up this handy dandy calculator here. And so we had log, what was that again? 2.5 over 2 over 4 of 2.5 divided by log of 4. And our answer to the nearest thousandth is 0.66. The 9 writes up the 1. All right, but I want to show you that you can do the same thing with ln. It doesn't matter which one you choose. ln of 2.5 divided by ln of 4 equal, look at that, same answer. Okay, so it doesn't matter which one you choose. They both will turn out to be the same. So my answer is 0.661. Okay, how about this one here? Log base 2 of negative 2.2. Okay, if we set this up in the change of base, let's say we use ln this time. ln negative 2.2 over ln of 2, right? Negative 2.2 comes here, 2 comes here. Oh, but you know what? I remember something, right? X, I don't know what that was. X, A, and B all have to be positive. Well, this isn't positive, right? No, I know you're answering my questions at home. And so this one's no solution or undefined because you can't do that. All right, that's pretty much it. I know these videos are going to be a little bit longer because logs are so new. So, see you in class. Goodbye.